Hello everyone. Today I'm here again with another chapter of class 10 mathematics where I'll be discussing about arithmetic progressions. So what we are going to discuss in this chapter? Let's see that. So first we'll be discussing about the basics which is related to the arithmetic progression. In short it is also called AP. Then we'll be discussing about the nth term of arithmetic progression, following which we'll be solving questions, and further we'll be discussing about some of first n terms of arithmetic progression, and then further moving on we'll be discussing about problems which will be based on these concepts. So starting with the first subtopic here, that is basics. So here let's talk about some of the terms which is related to AP and which we need to know before we go ahead. So first one is a sequence. So what is sequence? A sequence is an ordered list of elements where the elements are also called terms. Or in another way, we can say that a set of numbers arranged according to any specific rule. So that rule can be even logical also. For that, if you'll take the example, so example we can take it as like 2, 3, 5, 7, 11, 13 and so on. So what logic is relating the elements here? That is a prime number. So in this case, all the list of numbers what we have written here is a prime number. So in that case, if we have to write down the next few numbers, we'll be looking for prime numbers. Whereas we can also have the examples like set of even numbers. So 2, 4, 6, 8, 10 and so on. Next, when we talk about progression. So progression is a sequence which is defined based on a specific rule. That will be based on a definite rule. Here, if you'll take the example of it, like we can say 1, 3, 5, 7, 9, 11 and so on. We can even take 2, 4, 6, 8, 10, 12 and so on, and it can be any other pattern. So the basic difference between the sequence and progression is, for progression we can write a formula which can give any term of that sequence. Whereas when it comes to the sequence, we cannot write such formula based on which we'll be always getting any term which we would like to find. So that's how we can distinguish between the sequence and progression. Next, we'll talk about series. So what is series? Series is the sum of the terms of a sequence. In this case, if you'll take, for example, like if you'll take 1 plus 3 plus 5 plus 7 plus 9 and so on, so it will make a series. We can take 1 square plus 2 square plus 3 square plus 4 square and so on, it will make a series. We can also write 1 minus 2 plus 3 minus 4 plus 5 minus 6 and so on. Here the dot 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 indicates this sequence will be going on further. Next we'll talk about the terms of the sequence. So let A1, A2, A3, A4 and so on up to An, or we can write T1, T2, T3, T4 and so on up to Tn be a sequence, then A1 or we can say T1 is first term, A2 which is also T2 is known as second term, A3 or we can say T3 is third term and so on. We can write An or Tn which will be nth term. So this way we can represent the terms of a sequence. So the values separated by comma will be representing the terms, and the terms can be denoted by either the symbols A1, A2, A3 and so on, or we can represent it by T1, T2, T3 and so on. In our case here, we'll be discussing only using the terms A1, A2, A3 and so on. But if you would like to do, you can use T1, T2, T3 and so on also. Let's talk about the first question here, which says that find the first 4 terms of a sequence defined by an equals to n square plus 2 upon n plus 1. So these type of questions are simple to find. We have to just replace n with 1, 2, 3 and 4 and we'll be getting the value of the respective terms. So an is n square plus 2 upon n plus 1. So a1 will become 1 square plus 2 upon 1 plus 1, which will be 1 plus 2 upon 2, that is 3 upon 2. a2 will be 2 square plus 2 upon 2 plus 1, which will be 4 plus 2 upon 3, that is 6 upon 3 and that is 2. a3 is 3 square plus 2 upon 3 plus 1, which will be 9 plus 2 upon 4, that is 11 upon 4. a4 will be 4 square plus 2 upon 4 plus 1, which will be 16 plus 2 upon 5, that is 18 upon 5. So therefore, first 4 terms of the sequence are 3 upon 2, 2, 11 upon 4 and 18 upon 5. So let's talk about the arithmetic progression now, as we have seen the basic terms which we'll be using in this chapter, that is sequence, progression and series. So what is arithmetic progression? An arithmetic progression is a sequence of numbers where each term is obtained by adding a fixed value to the preceding term except the first term. Now here the fixed value is called common difference, which is denoted by D, which can be positive, negative or 0. So here if you will take, let A be the first term and D be the common difference, then the sequence of AP will be A plus D, A plus 2D, A plus 3D and so on. Now let's talk a little bit more about the common difference and see how we can find out the common difference when a sequence of AP is given. So let A plus D, A plus 2D, A plus 3D and so on, AN minus 1 and AN are in AP. Then D will be equals to A plus D minus A. D will be equals to A plus 2D minus A plus D. D will be equals to A plus 3D minus A plus 2D. So we can also write it as A2 minus A1. This is A3 minus A2. This will be A4 minus A3. So what we see here is the common difference can be obtained by subtracting the next term minus the preceding term when the two consecutive terms are known. So this way, if you try to write a general formula for common difference, it will be D equals to AN minus A of n minus 1. So using this formula, we can find out the common difference if we know any two consecutive terms of an AP. Moving to the next part, where we'll be talking about the general sequence of AP, or we can say general form of AP. So a plus d, a plus 2d, a plus 3d, and so on is known as general form of AP. So this is the generally sequence which we'll be taking whenever we have to assume a sequence of an AP. Now let's talk about the nth terms of an AP. So if a plus d, a plus 2d, and so on up to an are in AP. So now we want to find out that what will be the nth term in terms of a and d. So here what we see is the first term, that is a1 is a, second term a2 is a plus d, third term a3 is a plus 2d, and so on. Now a1 also can be written as a plus 1 minus 1 into d. 1 minus 1 will be 0, 0 into d, that is 0, so we'll get a. Second term, we can write it as a plus 2 minus 1 into d. Third term, we can write a plus 3 minus 1 into d. So what we see here is, any term if you have to find out, then it is a plus number of term minus 1 multiplied by common difference. So this way, if we want to find out an, then it will be a plus n minus 1 into d. So this is the nth term of an arithmetic progression, where an is nth term of AP, a is first term, n is number of terms, and d is common difference. So here there are 4 unknowns. So at any point of time they can give 3 of the unknown and they can ask to find out the 4th value. Or they can relate the questions based on it to the pair of linear equations in 2 variables, where they can give any 2 terms and then further they can ask to find any other terms of that arithmetic progression. Next, let's talk about how to find out any term from the end of an arithmetic progression. In this case, let us suppose we want to find out kth term from the end of an AP. So there are 2 ways by which we can find the kth term from the end. The first method is that step 1, we will reverse the sequence of the given AP. As we know, even if we reverse the sequence of an AP, the obtained sequence will be still in AP with the change in the sign of common difference. Step 2, find the kth term of the obtained AP from the beginning and so in that case the obtained value will be the required value. That means when you reverse the sequence on FAP and find the kth term from the beginning, that becomes the kth term from the end for the given sequence. Method 2. In this method, we are not going to reverse the sequence of an AP. We'll try to find out the kth term from the end without changing the sequence of an AP. So here kth term from end will be equals to n minus k plus 1th term from the beginning. That is, if you want to find out a kth term from the end, which will be equals to a of n minus k plus 1th term from beginning. In this case, n represents the number of terms of that AP. Moving to the next part, we'll talk about some of the basic things which we need to remember and some important result which will be based on nth term of an AP. So first point we'll discuss about is that if A, B, C are in AP, then what we find is that A2 minus A1 will be equals to A3 minus A2, which will give C minus B equals to B minus A. Further, when we solve it, we'll get 2B equals to A plus C, and then we can write B equals to A plus C upon 2. So, middle term is the average of first and the third term. It is an important result which we'll be using at many places while solving the question. Second point is, if an is an plus b, that means if nth term of an AP is a linear expression, then the common difference will be equals to A, which is also the coefficient of linear term, that is n. So this is all for this particular session. In the next session, we'll continue with the further discussion of this chapter. Thank you. Take care, everyone.